hi people. Notes 4.9 are moving back and forth between different forms of quadratics, which are the different forms that we have on our summary sheet here. So we've got factored form right here, we've got vertex form, and we've got standard form. And so we have that here as well. So we've got factored form, vertex form, and standard form. And this little graphic organizer will show you how to go back and forth between all of these different forms. So in our first example, it says write the quadratic y equals 2x squared plus 12x minus 32 in vertex in factored form. So for starters, we have to recognize that this is in standard form. And if you've noticed, I've color-coded this all so you can see how we're going to do all of this stuff. So to go from standard form to vertex form right here, it says that we have to complete the square. So let's talk about how to do that. So let's talk about how to get to vertex form. So here, if my equation is y equals 2x squared plus 12x minus 32, what I need to do here is I need to factor out that 2 from the first two terms that we have here. So I have an x squared left over plus 6x. I'm going to leave some space. I'm going to write down minus 32. Now I'm going to go through this process rather quickly because this is practice. This is stuff that we've already learned. But if you need a refresher on how to do that, you can go back and revisit the video on completing the square. So I'm going to take the b value, this new b value that I have here after I factored out the 2. I'm going to divide that by 2 and then I'm going to square it. So 6 divided by 2 is 3 and 3 squared is 9. So I'm going to add 9 and then I'm going to subtract 9. And then if you remember, this is the perfect square trinomial. So here I'm going to copy down y equals 2 and then I'm going to factor this perfect square trinomial that we have here as x plus 3 squared. So just a reminder that this right here is x plus 3 squared because when I expand it out, I get this x squared plus 6x plus 9. So right here, x times x gives us this x squared. X times 3 gives us 3x. 3 times x gives us another 3x. That's where the 6x comes from. And then 3 times 3 is 9. Okay, but if you remember, it's only this that's the perfect square trinomial. So we have to get this minus 9 out of here. But don't forget, it's two sets of this minus 9. So 2 times negative 9 is negative 18. And then I'm just going to copy down the minus 32 that we have right here. Put these two terms together, we get negative 50. So our answer here is y equals 2 times x plus 3 squared minus 50. So this is what this is in vertex form. All right, so now how do I go from standard form to factored form? And it's literally what it says to do. We have to factor it. So let's go ahead and write out factored form. And I'm going to start by writing out y equals 2x squared plus 12x minus 32. Now remember, whenever we factor, the first question we ask ourselves is there GCF? I'm going to factor out a 2 because there's a 2 in common with all of these terms. And I'm going to factor it out of every single term because in factored form, I factor everything. I only factor it out of the first two terms in completing the square. They're two different processes. And then I'm just going to go ahead and factor this expression that we have right here. So I would get x plus 8 and x minus 2. How did I do this so quickly? Because 8 times negative 2 is negative 16 and 8 plus negative 2 is positive 6. Okay, if the factoring is a little bit of trouble for you, just let me know and we will work on that as well. Okay, so I want to make sure that I did this correctly. So I'm going to graph out all three forms that I have here. Standard form, vertex form right here, and factored form, which we forgot to write out that this is factored form. And I'm going to see if all of these are equivalent to each other. So let's go ahead and do that. So if you notice right here, the first form that we have here is standard. This is vertex. This is factored. Let's turn on standard form. This is what our parabola looks like. Let's turn on vertex form. They are on top of each other. Standard is in red. Vertex is in blue. Doesn't matter which one I click on. They're going to be exactly the same. And then lastly, in green, we have our factored form. They're all the same thing. So all three of these forms are equivalent to each other. All right, in our next example, we're asked to write the quadratic in standard and vertex form. So clearly we know that this is in factored form because that's the only one that's left over. But also, how do we know that this is in factored form? Well, we know it's in factored form because it's literally factored, right? So let's go ahead and write on top of here that this is in factored form. And let's look and see what this says up here. So to go from factored form to standard form, what I need to do is I need to expand and simplify. That's what it says right here. I have to expand and simplify. So that's what I'm going to do right here. So let's write out standard form. I'm going to write out y equals 5, and then in brackets, x minus 4, x plus 2. Now, it doesn't matter what order you do your multiplication in. You can either distribute the 5 through first, or you could multiply x minus 4 by x plus 2. You could even distribute the 5 through to the x plus 2. But you cannot distribute the 5 through twice, because then you're multiplying by 5 2 times, and that's not allowed. So what I like to do is just get rid of the hard part first, and I'm going to expand this part right here first. And I'm going to, you can use FOIL, whatever you prefer, but you have to understand that you're going to multiply the x through to the x, which is x squared, multiply the x through to the 2, which is 2x, multiply the negative 4 through to the x, which is negative 4x, and then multiply the negative 4 through to the 2, and you get negative 8. Now, at this point in time, you could either collect your like terms, or you could distribute the 5 through and then collect your like terms. It doesn't matter. Either way, you'll get the same answer. So I'll just go ahead and collect my like terms, and I know that these two terms together give me a negative 2x. So then when I distribute that through, I get y equals 5x squared minus 10x minus 40. Okay, and now I have this in standard form. I've got the ax squared right here, I've got the bx right here, and I've got the c right there. So this is in standard form. Now we need to move this to vertex form. So let's take a look at what our graphic organizer says up here about vertex form. So to go from factored form to vertex form, we have to convert to standard form first. So if you look right here, we've already put ours in standard form, and now I want to go from standard form to vertex form, and the way that I do that is by completing the square. So more practice with completing the square from standard form. So don't forget, the first thing that we need to do is factor out this 5 from the x squared and the minus 10x term. So when I factor out that 5, I get x squared minus 2x. I'm going to leave a little bit of space. I'm going to write the minus 40 at the end. Now I need to complete the square. This is not a perfect square trinomial yet, so I need to complete it. So I need to know what number is missing to make this a perfect square. So I'm going to take this b value right here, divide it by 2, and then square it. So when I divide negative 2 by 2, I get negative 1. And negative 1 when I square it is positive 1. So here is plus 1, but I can't just add 1. I also have to subtract the 1. So this right here, I have completed the square. This is a perfect square trinomial. So when I factor this, this becomes x minus 1 squared. And then I get y equals 5 times x minus 1 squared. But I have to get this minus 1 out of here, because that's not part of my perfect square trinomial. But it's 5 sets of minus 1. So I'm going to subtract 5 and then copy down the minus 45. Or minus 40, sorry. My brain's working too fast. Put those two numbers together, you get negative 45. So here I get y equals 5, and then in brackets, x minus 1 squared minus 45. And this right here is my answer in vertex form. If I were to graph all of these out, all three of these forms on Desmos, they would all match up. If you want to do that on your phone, feel free to do so. All right, in our last example, we are given our equation here in vertex form, and we know it's in vertex form because of that x plus 7 quantity square that we see here. So let's look and see what to do here. So to go from vertex form to standard form, we have to expand and simplify. To go from vertex form to factored form, we have to convert to standard form first. So we're going to put everything in standard form first. So when I want to put this in standard form right here, I'm going to expand this x plus 7 quantity squared. So I need you to be extra careful and remember this x plus 7 squared means I'm going to multiply x plus 7 by x plus 7. So here I'm going to expand this. So x times x is x squared. X times 7 is 7x. 7 times x is 7x. And then 7 times 7 is 49. And then I'm going to write the plus 27 at the end. Okay, then I'm going to actually distribute first this time. I know last time I said I would collect my like terms, but I want you to see how it doesn't matter how you do it, it will still always work. So I'm going to distribute the negative 3 through to everybody inside of the brackets, and once the brackets are closed, I'm done distributing. So negative 3 times x squared is negative 3x squared. Negative 3 times 7x is negative 21x. Negative 3 times another 7x is another negative 21x, and then negative 3 times 49 is going to be negative 147. Then I'm going to add the 27 at the end. Okay, so here, now I can just go ahead and collect all of my like terms right here. So this ends up being negative 3x squared, nothing's like it. Minus 21x is like minus 21x, and that gives me minus 42x. And then here I've got negative 147 and 27 together will give me negative 120. And this right here is in standard form. Now, to be able to go to factored form, if you remember, it said that we have to put it in standard form first. So I'm going to use standard form. And to factor this, I need to go through and see what's in common with all three of these terms right here first to see if there's a GCF. Also, because the leading coefficient is negative, I for sure want to take out that negative. They're all divisible by 3. So when I factor out a 3 here, I get x squared. When I factor out negative 42x divided by negative 3, I end up getting positive 14x. And then when I divide negative 120 by negative 3, I get positive 40. Then I'm going to try to see if I can factor this right here. This is nice because I know x squared is x times x. I know that 40, some factors of 40 would be like 1 and 40, 2 and 20, 4 and 10, 5 and 8. I would like to use 4 and 10 because I know that positive 4 and positive 10 would give me 14 when I add them together. And this right here is my answer in factored form. And again, you can go ahead and double check on Desmos if you would like. But that's all we really need to do here. All right, that's it. Let me know if you have any questions, and I will see you in class. Bye.